Well, all right, everyone. It's 6:18, so I think we're going to get started. So, Zach, you want to go ahead and introduce us?
Yeah, let's get started here. We've actually got pretty much the whole core team here. So obviously myself and you normally do these. We've also got Chuba and Rabbi with us, both core members. Chuba handles. He's also kind of our second developer in a way. He does a lot of our on-chain stuff. Really skilled in that department. And then Rabbi and myself, we handle some of the less technical things that you and Chuba do the heavy lifting on. So I'm really excited to have all of us on here today because we've got a lot to talk about. As always, we've been kind of hard at work, but we haven't had a chance to really go in depth about some of our on-chain integrations, some recent developments that we've had on that front. So, I think we can kick it off from the top and maybe start with like a high-level overview about on-chain deployment and what that might mean for us here in the near future.
Yeah, well, this is an interesting aspect of the project that in many ways sort of gets overlooked by the kind of the grander research scope. So as people know, like we are, a tokenized project on the blockchain. We have the tchotchke token that, is probably for a significant amount of people the main drive of their attention and interest in what we're doing and the project. And I mean, for a lot of even people in our core community, sort of the attraction to the token itself was sort of the thing that kicked it off, and then they sort of got into the science and the quantum computing and the tech and the sort of the grander scope sort of as a function of that. But and a lot of the focus gets sort of put on the research itself and sort of the direction of the company in terms of our grander sort of off-chain offerings that sort of affect real-world development and sort of larger scale influence in the technical market, et cetera. But we don't actually spend that much time talking about our relationship to sort of crypto as a whole, and what our sort of interests are in terms of what we want to do in the future, what kinds of things that we are doing in the present, and also just sort of theoretical interests, because I mean, there's probably an interesting intellectual divide going on in the world, no doubt rooted in disparity of political and economic and social viewpoints. But cryptocurrency actually has a lot of very interesting intersections with, topics like quantum computing and AI and robotics and all kinds of very, very interesting subjects that are all dominating various forms of the conversation across the entire world. And whether it's for a sort of a marketing mismanagement or just a social perception or for some other reason, there maybe isn't as much consideration in the sort of the grander intellectual and research community outside of people that specialize, say, in cryptography and stuff like that, for sort of the greater applications and viability of things like on-chain deployment. So I mean, like the notion of sort of cryptographic, we call them currencies. I mean, it's an interesting idea that someone thought that you could take something like the proposal of Satoshi's Bitcoin and turn that into a viable commodity, because in actuality it is basically a system for managing, well, not just contracts, but sequentiable sort of cryptographically or mathematically secure operations in a collision-free environment that we refer to as, a hash table or as a sequence of hash functions. So, I mean, the idea that like cryptocurrencies themselves are just these like, things that have some sort of vague, commercialized, asset category or something like this, or merely a collectible or merely whatever, is really like a misreading of the technology, because like what cryptocurrencies, again, a misnomer, just as much as an idea like a meme coin is a misnomer. These sort of cryptographic, conceptualized public based ledger technologies, we call just for short form the blockchain, have applications that go way beyond just buying and selling. Although when you think about it, what in the world isn't in some sense related to some sort of transactionalized, economic activity of some kind in which like there are unitary exchanges taking place? I mean, like literally everything from the air that we breathe, where we take in like one, let's say unit, a lungful of, air, nitrous and nitrogen and oxygen. And, we export one unit of, say 60% carbon dioxide or something like that, that gets used by, the plants and the ecosystem and stuff like that in this kind of, ongoing exchange process. I mean, like that's all basically tokenizable on a purely molecular level. So just on the basis of like, the concept of this kind of unitary exchange itself on some sort of transactionable open ledger, it goes way beyond just like some of the most superficial aspects, and it does actually delve into some pretty deep territory in things like scientific computing and mathematics and just economics and social theory and whatnot as a whole. So this is a really interesting opportunity because we're going to talk about a lot of really concrete stuff in terms of like what we're actually building, what we can build, what other people are building, and what the potential applications of such things are. We can also talk about sort of the more grand, view of how the world itself is like an ongoing cryptographic problem, and how the sort of emergence of these technologies when they did around say 2008 2009 actually solved quite a few interesting social problems and created a few more while it was at it. As Andrew McLuhan would say, any sufficiently advanced technology is equivalent to a sufficiently advanced social problem. So it's an interesting ongoing conversation that should involve more minds in the scientific community, and very likely it will once the viability of sort of decentralized science sort of becomes applicative to the point that it becomes a turnkey solution for basically any kind of team or research project in the world. So I think this is going to be a really interesting conversation.
Yeah, I mean, I think maybe we should start from the top with, specifically about something that is concrete, which would be, I know we've talked about, the QRNG in the past. A lot of people are familiar with your QRNG deployment, but I don't think a lot of people are aware of what that necessarily means about what that could mean for being actually on chain, both the benefits for the chain and necessarily why that would benefit. So I think you and Chuba can probably dive into that.
Yeah, absolutely. So I know we've had a whole bunch of other spaces on how the QRNG works, so I'm gonna try to not get into that. And then Chachki, if I do veer off, please correct me if I'm going off base on the quantum tech. But from the chain side of things, it's really interesting, especially on the Solana side. Um, I've worked with a lot of the on-chain VRFs on Solana, and it's kind of it's an issue with any budding new chain. Solana is a chain a lot of users like, but builders have had a really hard time with it. Um, so when you think about just on-chain RNG in general, Ethereum mainnet and any kind of chain that has the Chainlink offerings usually has a pretty robust solution, and this works for some use cases and not others, depending on how fast you need the random numbers, how much you're willing to pay, and so forth. But much like the Chainlink kind of alternative, you can think about how the participants who would like to get random numbers would need to put up tchotchke tokens to make a request and receive that RNG within basically a fraction of the second on the blockchain, fulfilling, whether it's a random number they need to match two players together in a game, or, something much more kind of useful than that, where quantum numbers really do start to move the needle, especially when if you're pulling that into AI applications and so forth. Um, so yeah, from my perspective, I'm super excited about kind of the on-chain tech that we have, um, uh, especially on the Solana side. Kind of leveraging all of the Solana technologies that you do smart contracting in, Anchor, Rust, all of that good stuff. Essentially providing a Oracleized system for the QRNG, much like Chainlink with similar kind of economic flows. So yeah, super excited for that to go live with the launch partners.
Yeah. So as Chuba's saying, there's a lot of really interesting applications for why you might want a tokenized random number. So the most obvious one that I am interested in, because I mean, this is something that I think is one of the most direct applications of these so-called cryptographic currencies, is for the sake of so-called, events management or sort of time-based contracts. So there are many reasons why you need a random number. One could be generating a username. One could be, you're seeding the generation of some, unique asset or something like this. So, for example, in the NFT world, you might eventually see, if we continue to get like number generation on chain and data storage on chain. Like, I'm really interested in vectorized geometric data storage on chain. So, like, I don't know if people realize this, but I mean, many of you probably know that I've deployed NFTs on Tezos as part of like the Analog Video Union, of which like I'm a member, and many of my friends are involved in that enterprise, and it's something that a lot of very cool people work on, and Tezos has brought together a lot of really interesting artists and people like that, and I'm very grateful for the experience that I've had on that chain, especially because that was really my only real introduction to any kind of cryptographic art, culture, or anything like that exposure prior to what we've been basically building with Tchotchke, which is sort of a cultural production engine associated with this sort of collectibilized token that directly corresponds to a social movement related to our research stream and productive R&D outputs. So it's a really cool thing what they have going on there on Tezos. Like, I deployed a lot of stuff on Object myself, but the problem is like a lot of stuff really can't fit on chain itself. Like they end up storing the files on specific places, and what you effectively get is a database that points at what it will one day eventually be like a dead link somewhere, because it's not going to exist that you could have some kind of perpetual storage. So ideas like vectorizable container formats that allow for totally decentralized reproduction of, say, lossless material. I mean, this would be a much more grand project, sort of on the long scheme of things. But Solana, being as high velocity as it is, could actually be used as a like media storage format of some kind for some kind of distributed streaming platform or something like this. And that's where the idea of being able to rapidly generate random numbers becomes really effective, because it has applicability both for like user management in terms of like, being able to track attrition over, very complex like networks, or even just like things like aberrant behavior and stuff like that. Or, for example, being able to incentivize and reward people across many platforms or something like this based on effectively general behavioral or usage metrics or something like that. All these sorts of things like make the application of true quantum randomness on chain that much more valuable, because beyond just being able to eventually store actual cohesive data on chain itself in a way that you basically utilize a completely distributed platform as a sort of BitTorrent like object oriented data storage store or something like this, for a low footprint, like low data format, like a vector storage warehouse or something like this. This is sort of one of the main areas where I see, like, beyond just the Oracle aspects of what Chuba is talking about are extremely important, because, like, as we identified, like, there's a existing usage case for this exact particular deployment of like a random number generator on blockchain that would provide that true randomness that would suffice for a secure contract on chain, or a specific unique deployable identifier or something like this. But there's also beyond that, the capacity for minting basically directly, if you want to say, on chain, as opposed to say these required off chain sort of centralized data storage things. And that's actually what leads into our more sort of complex conversation, which is sort of what are the actual ways that we can utilize like true randomness on chain that allows us to effectively deploy technologies that are otherwise basically impossible. And so I think that's where the question sort of changes from like a purely technical like offering of like what we can do, which I think is an interesting conversation in and of itself. But more interesting would be what sort of applications and the sorts of ideas that could be spawned from such a thing. So I don't know, are there any particular examples anybody wants to bring up, or like is there like, I think one of the most obvious examples would be toying with the notion of having a true a contract system, not unlike what you might call, say, a corrected sort of reinterpretation, not exactly a hard fork or something like this, but what if Bitcoin from the beginning, for example, had been intended to be exactly solvable on a post quantum cryptographic network, in which like the actual hash solving functions themselves incorporate things like higher order factoring, and true quantum randomness. Like, what if, like, in the near future, the immediate applicability of high speed quantum randomness leads to effectively being able to use noded or nodal sort of hubs of specific sort of quantum classical architectures as effectively verification centers that can be used sort of interchangeably, or sort of just hot swapped for um, potential data filtration, or cryptographic solution, or even solution generation places in contract management. So I think like the sort of immediate applications of, and again, like there's a huge conversation that takes place around the idea of post quantum cryptography. I mean, there are many projects whose sole devotee is post quantum cryptography. I mean, I can't tell you how many links have been sent to me in the last like 3 weeks of just like project after project of offer to provide some sort of post quantum cryptographic regime of blockchain technology or something like that. But I guess what I'm saying is like the idea of adapting like actual true quantum computing to the contract management system we call the ledger, becomes a really interesting statistical and economic problem that I think like deserves a lot more attention, and I think we're going to shine some focus on that in the very near future as we introduce the general public to the idea and the utility of true quantum randomness on the blockchain.
Yeah, Tube, I didn't know if you wanted to add anything else to that, but I just kind of wanted to. I don't know how many people in here. I think there's a lot of them, but since the very beginning of this project launch, like we have been talking about doing real things on chain, and we really kind of front ran the meta of people doing that, and now we're going to start actually doing that. Like Chuba said, Solana has been notoriously hard for builders to do things on chain, and so I think with what we're doing with quantum computing and now bringing this on chain, this is going to be, I think a lot of people are having a hard time framing just the reality of what that actually means. A lot of this stuff is like a pretty high level overview, but there's a reason why you can't really point to many other projects right now, because they don't exist, that are going to accomplish what we're accomplishing here. And so we're definitely in the right place at the right time. I don't know if you guys want to dig in any more on the QRNG stuff, Chuba or Chachki, if you've got anything else up to this point.
No, on the QRNG stuff, I think we're good unless Chachki, you have anything else to add there. And then,
Not really. I just will say that, like, related to the, reducing the footprint and stuff like that, like the idea of deploying the QRNG directly on chain in the form of, say, some kind of sub Oracle WASM kind of implementation is definitely on the plate, and something that we are going to be doing. So we'll be deploying the Oracleized sort of version, kind of a lot more soon in the temporal kind of point of view. But I'm very interested in actual literal on-chain co-deployable, transactional stuff involving random number generation, and also solving a bunch of hard problems, like how do you generate something non-deterministic in a purely deterministic environment. Like, obviously we're going to have to hand wave some things, but I think in the context of what we need for that sort of structure, I think we're going to be able to accomplish it. And I've actually already solved most of these problems in a fairly satisfactory way.
yeah,
But,
and
yeah,
not to front run you, Zach, but maybe that's a good segue, Chachki, to putting your kind of core dev hat on, if you will. I don't know if many people have seen Chachki wear this hat, but you kind of just got a sneak peek of him starting to think through overcoming solutions to existing kind of blockchain limitations and problems. And I know there's a bunch of ideas you've been discussing with a bunch of really cool people around the throughput on the Solana blockchain and other kind of really interesting problems around scalability. So I'm curious if we want to talk about that for a few minutes.
Oh yeah, I think we should, and I think so. There's a lot of ongoing conversations in the sort of the cryptographic community, or crypto tech community, if we want to kind of rebrand everything sort of away from the pure asset management aspect of a tokenized asset to the sort of applicable underlying technology. So, as people may or may not know, like, there are these sort of underlying cryptographic protocols that sort of actually govern the exchange of these transactions on ledgers. So famously, there's everybody knows about Bitcoin, and there have been some interesting things that happened in the last decade or so with regards to forking and the creation of, for example, Bitcoin Cash. And Ethereum chronically suffers from its various sort of network issues, and then everybody forks that to make all kinds of interesting things. And then so the Solana ecosystem is sort of unique in its own way, that they sort of solved this kind of forking problem by just allowing people to make like aliases of the sort of the supra technology that exists on top of it, of which like Art Token Chachki is one of them. And Solana is a very attractive network for a multitude of reasons, mostly because of its high velocity, which leads it to be, this secondary sort of trading market that exists sort of outside of the stock market. So, not saying they're the same thing, and even the SEC themselves don't think it's the same thing, and they literally just branded meme coins as like collectibles or something like that, which I think is a pretty boomerized way to think about it. But hey, like, we'll take what we can get, nevertheless, Chachki is not a meme coin. I think everybody understands that we are sort of our own asset class, if we want to call it that, or if you want to think about a pain in the asset class, right? But the point is, we're really interested in sort of the underlying protocol, sort of data centric things that are happening on chain, in ways that we can improve it. So, one of the ways that you can think about what's going on in Solana is sort of like a permissionless, trustless network that's going on, in which, like, there's sort of a mesh transport layer in which, like, raw information sort of gets packed into these, like, little forms, and then sent out to this network in in an hopefully anonymized, purely non-distributed or a non-centralized way. Of course, like as we've seen recently, there's a lot of very big problems with regards to, when you have really large liquidity soaking situations like what we saw kind of in that interesting event that occurred, back in January. Are there ways of overcoming this? Not just overcoming that itself, because it really has more to do with like how can you increase rapidity? How can you increase decentralization? And how can you make the network more viable in terms of like, some reliable transactional system in which like, it means faster efficiency or faster, more efficient, higher fidelity, less dropped contracts, less dropped transactions, and more secure and error corrected transactional exchanges. So many technological systems work on the basis of not distributed, but error correction. In the context of a distributed blockchain, you have to think about it as a distributed problem, which leads very interestingly and directly into sort of these quantum networks. And that's where, I really feel like in the grand scheme of things over the course of, a relatively, let's say, short to medium term scale, you'll see us sort of getting more involved in sort of the ongoing discussion about how to increase fidelity and error correction and data sharding and block size increase across the chain. But then sort of on the medium scale, you'll actually see us sort of taking a front leading role in terms of like, how do we actually deploy sort of quantum scale technologies? Because if you think about it, if we're going to go to the trouble of, replacing some sub function of the chain for the benefit of, this major sort of, improved environment, why not go the extra mile and actually, make the thing truly modular and future-proof in a conceivable way. So Solana will become basically the first of many, hopefully, God willing, examples of sort of future-proof on-chain deployable sub protocol network solutions in which like Tchotchke technology directly influences future development, but also immediate deployable sort of utility scale, dev scale processes. But also we will be hopefully moving that onto the greater sort of crypto ecosystem as a whole. And this is sort of where the conversation about a toy blockchain sort of comes in, because we have the opportunity to sort of like deploy a potential system that could serve as a model upon which like other things could effectively be based, that would also have its own intrinsic value that could potentially be utilizable in some interesting or experimental way that might be very aesthetically or conceptually interesting to us or to the greater public or something like that. But this is where the idea of being able to create sort of a arbitrary deployable quantum toy blockchain would really serve as a good potential use case, that again, certain aspects of the technology could just be wholesale imported into effectively every chain, but then it would just also serve as sort of an idealized representation of what maybe Bitcoin could be. I don't know if anyone has been thinking about what the potential ramifications of quantum computing would be for mining on the Bitcoin blockchain. I mean, there will be an initial spike of, very successful short time mintings on the Bitcoin chain. It's going to be very interesting when that occurs, because there's going to be a very brief period of time where like the chain undergoes like a halving in like an extremely short amount of time or something like this. I don't know if it'll be like a whole halving or something, but it'll be, you know, like a really massive number of like transactions that happen immediately. But then like the difficulty will like shoot up like exponentially because like, you know, the interesting thing about Bitcoin is it has this kind of exponential difficulty scaling rule. So effectively, like as the ease of mining it like approaches, you know, conceivability, then the like the amount of energy and like time required to solve a problem also increases. So like, you know, it would be interesting to see what the upper limit scale for like solvability on like a short enough time scale that you could sort of, you know, statistically overcome the sort of actual inbuilt difficulty of Bitcoin would be, you know, given a hypothetical infinitely powered quantum computer, something like this. Might be a potential paper worth writing. It might even be an interesting thesis topic if somebody wants to write a PhD. But the point is, you know, that's something that I think like we could, you know, do in the sort of the medium term, as an example to the world, so to speak, but sort of more in the short to medium term. I think like, you know, the application of quantum distribution to error correction codes for things like Solomon Reed systems, like the kinds of things you see in commercial data storage fidelity applications, like even the mini disk, for example, or CD, you know, you know, prevention, copyright prevention technology and stuff like that. I think that's where you're going to see like sort of the immediate applications of actual quantum computing, actual, you know, sort of quantum algebra to the sort of the solving the grander problems sort of on the chain, even in the absence of like say high qubit range computers or anything like that. So again, it's a really interesting ongoing conversation. I really want to stress this, that I don't fundamentally see quantum computing as being that different from classical computing. It just is a like sort of an extension in the same way that you can sort of think of like lambda calculus is basically being like an extension of sort of conventional computing. Like you can sort of reduce everything to lambda calculus. Like quantum computing is a universalized framework in which like classical computing is just embedded in it. So the problem is like we don't have like an idealized universal like continuous analog quantum computer yet, and we're probably not going to like for a relatively long period of time. Like the topological solution, you know, leads to, you know, some, you know, mitigation of a lot of the kind of immediate problems with gate-based and you know, gapped quantum computing, or what you want to say like photo capture, like ion cavity quantum computing, etc. Like so-called, you know, quantum dots. A lot of the like sort of the immediate term topological applications are really like error correction, stability, and you know, entropy, code sort of generation, etc. So really like the way that like you kind of extend the value of you know, short-term coherent states in like noisy quantum computers is effectively like by stabilizing the numerical output using classical computers and then effectively averaging over, you know, taking, you know, very, very short frames of coherence, you know, coherence lifetime, and using that, like you can you know, really get a lot of value, get a lot of, you know, high fidelity information out of the noise. And that sort of same application can be applied to, you know, all kinds of, you know, on-chain data sharding problems. So again, like the infinite applications of topological computing to any kind of data sharding or high distribution object-based you know, data generation or storage applications have effectively topological solutions.
Yeah, real quick, I just wanted to, because I think I wanted to give this a little bit of context. We might have, you know, glazed over it in the beginning, and then also I do have someone who raised their hand, but they also asked a question in our comment section that I think is relevant to what you're talking about. But just to frame this, so we did have a very well integrated company who's involved with solving blockchain problems, specifically as it relates to Solana. They approached Chachki with some papers and said, "Can you look these over and let me know what you think?" They're very familiar. We've been talking to them for a few weeks now, but they're familiar with Chachki's technology. They know that he understands quantum computing at a very high level, and so that's kind of how some of what we're talking about here, this conversation got started, was with those papers. Chachki spent a few days going over them. We've had some conversations since then, but the timing was really quite good because, as we've been talking about, like we've been wanting to, we've been talking about what it means to do things on chain. And so now that we've been approached by some of these companies, I think we've got a really unique opportunity. Chachki, you've kind of alluded to some of that with what you've talked about here, but I just wanted to let some people know that's kind of how some of this conversation initially got started. But as it pertains to this conversation, we did get a question. They asked, "Can biohybrid systems wetware solve energy issues?"
I really think we should defer to Chuba on this one. This sounds like something that you would love to speak about.
I'm not 100% sure I follow the question, to be honest.
It's a brain question. It's a biotechnology question relating to wetware. Zach,
Ah,
yeah, Zach, do you
If
want
you
to
guys
like
want,
me?
I can
Yeah,
actually let him. I can let him on stage.
let's let him on stage. That
Yeah,
sounds
yeah.
really
Let's
yeah.
cool.
let's
Yeah.
do that. Let me bring you up real
But
quick.
many of you don't realize this because Chuba is a on-chain specialist, but actually he has extremely advanced interests in biotechnical applications of neural networks and learning to these sort of systems where there's like kind of an overlap between like what is a machine and what is, say, a living entity and this kind of thing. And it does factor into this sort of the larger question of like what exactly is intelligence, like what even is wetware. I mean, are we going to pardon me, are we always going to refer to hardware as hardware, like, or are we going to one day generate it by like a purely chemical process that like is so like similar to what we call biology that like it becomes indistinguishable? And of course this gets into an even grander sci-fi question of, is that already the reality that we're living in right now? Are we ourselves some kind of biomechanical androids? Anyway, thank you very much. I see that we have a friend on stage, so yeah, go ahead.
Hey guys, thanks for having me up. I've been following you guys from the start. I fucking love this project, and I think you said it best. Are we not like bioelectric, electromagnetic or biochemical computers already? Um, I think that the problem with consciousness, like sentient, self-aware consciousness, is an emergent thing, and I see a lot of a lot of people try to solve it with what would you say, with compute, right? So can we make the metal fast enough and powerful enough, and can we make the algorithms logical enough and varied enough, and can we make the databases large enough and knowledgeable enough? And I don't think that's how it's gonna it's gonna go down. I think what that gets us is a very, very good mimic of a sentient being. What's up, Tubes?
What's up? What's up? Yeah, I think this is really interesting. And kind of, if I take a step back, right, and think about almost in terms of like, how might I phrase this? Kind of in terms of crypto, right? Like everybody wants to see a lot of things kind of, like we hear on-chain gaming, right? And a lot of my thinking on a lot of these things has always been the use the right tool for the right job. Put the things that make sense on the blockchain. Put the things that you want to make scalable. Use the best Web2 patterns for them. Build the fastest apps. Reframe this a little bit into like an AI context and learning systems and energy efficiency, right? It's really interesting that the pathway that we came to like all of this AI progress was a bunch of companies made chips for kids who liked playing video games on the computer, and those video games kept getting better and better and better. And those same problems that we had like in the video game industry, like all the linear algebra and math around this, also just happened to be like really relevant for all sorts of really interesting optimization and learning problems. But maybe in a really, like you're kind of suggesting, energy inefficient route to do it. So we kind of like brute forced it the first time around, and now that there's kind of like this proof of concept around optimization and learning, now we can start to look at all the other really interesting substrates, right? And so I know you're working on a lot of really interesting things, on exactly this topic, right, in terms of alternative substrates and biological substrates for things like learning systems. So yeah, all of that is like super excited to me, and I know Chachki and I have spoken a ton about a lot of these ideas.
Well, Troop, so I don't know like the energy. I'm not like a what do you call it? Like I'm not an enjobinologist, all right? Like I don't know the energy stuff. All I know is the second rule of entropy. That's it. That's as far as I go. And I know that electricity moves like waves, I guess. But in terms of like if we had a bio hybrid computer or wetware, sort of as the as like what would you say, interacting with the hardware that the LLM is on, would we be able to implement what you guys are building to even like to further that, like basically the compute of whatever the LLM's running on, right? So the GPU, can we use Chomsky for that?
Yeah,
Yeah, I think there's
quite literally. Yeah, go ahead. Go ahead,
maybe
Juba.
one. I was going to ask you a question there, Chachki, which is essentially like quantum phenomenon, right? Like things that you're particularly interested in. And there's always this fun question laymen have of like, when do these quantum phenomena observes? When are wave functions actually collapsed? As far as I know, this phenomenon does exist. Very much so in the kind of biological world, especially when you're kind of looking at this level of neurons. So I don't know if you have any kind of ideas there, but I
Yeah,
think there's a
so
lot to explore.
so this is actually something I've wanted to talk about for a long time, really quick. So the subject of observation in physics versus like what people mean in the common parlance. So actually a lot of my systems that I'm building are actually based on not collapsing the wave function actually. So it's kind of part of our marketing, observe me, destroy me, choose nothing, gain everything. So if you understand the idea of teleportation as it applies to, the sort of the gate symmetry issue in terms of like entangled qubits. So once you entangle a qubit, you can move them to like different parts of the system and they remain entangled, especially when there's like an electromagnetic pathway. Now, of course, we're dealing with an electromagnetic substrate that's effectively like continuous in this environment. So even though we are brute forcing it, so to speak, we have created this sort of like environment in which you can actually like have cohesive information transfer where you move things from one part of the system to the other. Now, the interesting thing is now you can operate in terms of like a quasi virtual set of like gate operations on one or both of the qubits. And then you can effectively, without collapsing that quantum state, transmit data effectively, what we would consider to be instantaneously. Yeah, this gets into a really complicated conversation about, the idea of simultaneity. A lot of people don't realize that in the context of like special relativity, there really is no such thing as simultaneity. Like it's impossible to say which observer saw which event first, especially given certain sort of observational characteristics or something like that. So again, like a lot of the sort of the misnomer, misconversation around like quantum computing actually relates to actually not understanding special relativity. But long story short, biological systems running on.
Wait, Chomsky, really
Oh
quick.
yeah.
Are you saying that the observer effect doesn't collapse the state itself? The observer watching it, the cut doesn't collapse the state.
Well, just to be clear, like when people talk about the philosophical application of the Copenhagen thing, they're talking about usually what they call the double slit experiment, and the double slit experiment is really like a difference of like when you look at bulk phenomena taking place in terms of like wave activity versus like information collapse to say like a detector. So the classical one is like when you're not looking at it, which means you are looking at it. Like anyone that's ever been to a university physics program has done the double slit experiment using actual like lasers, and you are looking at it. Like you literally are looking at it. It's just that when you take the measurements, so the again.
Right. That's how I understand
Yeah.
it. Is that the electron am I right? Is the electron or photon used to observe the quantum state causes it by touching it to collapse the
That's
state.
a really nice way of looking at it. So what Richard Feynman would say is when you look at the path integral, like there are like an infinite number of potential configurations in which the particle could have hypothetically gone, but if you actually sum over the history, you find out that all of those ones are canceled due to destructive effects, and the path that it actually took to get to the thing was like cohesively made by constructive effects. So basically it's exactly what you're saying in terms of common parlance, which is the thing effectively takes the path that was chosen for it. Of course, again, in the general quantum mechanical point of view, it actually literally does take every possible configuration. It just so happens to be that when you sum over all the histories, those non-physical paths cancel each other out.
Okay, dude, I need to. Well, we can talk about maybe another time, but I want to talk to you guys as we develop what we're doing as it gets more advanced. What I want to implement the quantum compute for is I want to see if there's a way that we can actually get because I think that quantum is it can give rise to para-deterministic
I didn't hear
systems.
I didn't hear anything you just said. You're gonna have to repeat the last.
Oh, do you guys hear me?
Yeah, you kind of
That
Yeah,
first
I can
couple
hear you
sentences
now,
there.
but
okay. Okay. So so in terms of consciousness and emergent consciousness, from some sort of like a biohybrid LLM, right? One of the reasons I wanted to use Trotsky is because I want to see if we can use quantum, given that it has these sort of emergent properties, to give rise to intelligence, because quantum is non-Newtonian physics, right? It's sort of even like it's paracausal, right, or paradeterministic. And what we're trying to do is just break deterministic loops or causal loops, right, in cybernetic systems, because that's what makes them. We think this is the thesis is that that's what makes them. That's what's keeping them from sentience. Is the new yeah.
I
Yeah,
just
and
want
I
to, sorry to interrupt. I just really want to just like red flag something really quick. I don't actually think consciousness is an emergent phenomenon because like that's kind of philosophically invalid, you know? It's far more likely that consciousness itself is based on some sort of like energy minimization principle that probably is even like sub organizational, so I'm more of what you might call like a panpsychist, but like a modified version. Like I'm sort of a monist in the sense of like primary generation from a singular source, like the effective the basic sort of modus operandi of quantum field theory, or string theory or something like that. But I do want to qualify that I actually think that the organizational principle that we refer to as consciousness is actually the necessary binding ingredient that makes the organizational properties of matter fundamentally viable. So just to be clear, the
yeah,
reason
I
why we
think
can build intelligent
calling it
systems is because intelligence is the fabric of the universe. Sorry.
calling it
Right,
consciousness kind
right.
of lets
Yeah.
you have like undergrad level conversations around it, which like I remember a lot of my undergrad like cog sci classes we were talking about like consciousness emerging from like microtubules and kind of those kind of principles, and kind of the potential explanations being around like quantum principles occurring within those microtubules. So maybe even if consciousness isn't explained away as an emergent property as a result of that, maybe there's some interesting room to be able to use that substrate to be able to run some of the algorithms that you're starting to design,
Well,
Chachki, for example.
should I just mention that like we've literally been talking about this for 3 months, and like neuromorphic computing is the like medium term trajectory of the company. So the real question comes down to it being an engineering and economics problem, and I think biology might end up being like the solution to this, because like what is a neuromorphic system? It's a spin based system in which like the actual it's spintronic, if we want to get into it. Like spintronics are a very, very interesting field. One of the main reasons why I even wanted to get into physics in the first place, when I got back into it professionally. The point is, spintronic based neuromorphic systems need to be engineered from certain substrate that make them, most viable for the kinds of things that, allow them to be, in the sense like putting the the intelligence into the system itself rather than into some supra process. Like, as you know, like the body itself, even in the neural system, neural nerve system, relates to, it has its own kind of subconscious activities. So what we call in our kind of common parlance, involuntary motion, right? Like, oh, a spider, right? Or something like that. Like your body seems to move by itself. It's like, yeah, it like quite literally does. The body itself possesses intelligence. All the subsystems do. Like bacteria possesses intelligence, man. Like, come on. The point that I want to make here is that it might turn out to be the most economically viable solution for like neuromorphic systems, that they are these kind of physical androids. Makes me think about the movie Blade Runner. That actually the reason why they built these replicant things that are effectively robots, but they're actual biological systems, is because it's actually cheaper and more energy efficient and faster and more viable to actually just do it on what we so-called wetware, instead of trying to engineer some kind of living thing. And as you guys know, like the proposal of a quantum neuromorphic system is actually literally in our original, now redacted, white paper. But the point is, um, in terms of a short-term like solution for testing the viability of a so-called neuromorphic. Now, it's not a true neuromorphic system because, well, I guess it could be made into one through the application of, other organs or, so-called sensors or something like this. The point being, neuromorphic computing, neuromorphic having the form of the brain, Trove. It kind of related to what Chuba was saying. Oh, isn't it a nice coincidence? I wanted to say, actually, I didn't want to interrupt you, of course, but you might call it the unreasonable effectiveness of gaming to the AI and generative computing industry, to quote or to paraphrase a famous Julian Schwinger concept. But basically, so I don't believe that we're going to see what we call emergence of consciousness. I think like when you have a sufficiently complex system, much like what Ludwig Boltzmann believed, you get a what you might call a like a mind, because effectively, again, as Max Planck thought, consciousness is the most fundamental substrate of the entire universe. And it might well be that there's a purely physical mechanism that generates what we call the effect of consciousness, but the effect and the like modal configuration are not equivalent to each other. Again, it's the difference of the philosophical sort of underlying conception versus looking at it purely mechanistically. But anyway, it's a very interesting topic, and of course, we have a lot of interest in that.
Actually,
Well, shots. I want to.
Can you?
Oh yeah, go ahead. Sir.
Yeah, just because I think you guys understand what you're talking about here, and maybe the potential collaboration you talked about. But can you actually just explain what Maiden Labs is? Because I'm actually not familiar. I think a lot of other people aren't familiar, and it'll help to frame this conversation a little bit better because we obviously kind of took a turn. But super interesting. I'd like to know what you're building.
Yeah. Okay. Right. So sorry. I didn't want to like shill it like that, but basically we're doing two things. We're building we're raising to build an actual brick and mortar lab where we'll like choose projects that can come in and like do stuff with brain. Mostly it's wetware. So we're going to be doing like different types of wetware stuff, brain organoids, human brain organoids, more that maybe more advanced models, but we're not looking at that yet. Fungal studies and stuff like that. Kind of like mad science stuff, like stuff that could actually be useful to the field as well. So the other side of it is the initial project, which is basically we have DeepSeek R1 model hooked up to a human brain organoid, right? So we're renting that out. We don't actually own the organoid itself. It's not in our possession. So we're renting it out from a facility, right? And I think we're going live with the. Well, I got to talk to Benny about that. I'm pretty sure we're going live with the data this week. But but whatever, verifying it, right? And so the mad science kind of part of it is like, can we build a as Chachki was saying, like a sufficiently complex system such that there are properties that emerge that are not immediately apparent in the parts which make up, the whole. And so that's sort of just the general idea of it. I want to do some really wild stuff. Of course, we're going to do like the agent stuff and everything, but the projects it's a mix. It's a mix of sort of meme entertainment and then also of real science and research. And so that's what we're trying to do.
Very cool. I've not heard of anyone else doing that, so I think that's super interesting. And just thinking about how Chachki's tech could necessarily integrate. I mean, where do you see, like, where's your biggest interest in terms of an integration there, and how would that benefit what it is that you guys are doing over there?
Ramelia Rabbi. Ramelia Rabbi is my biggest interest in this project. I'm
What's
joking.
up, bro?
What's up, man? No, our biggest interest with Chachki in particular is that, well, in part because Tubes is here, Ramelia Rabbi's here. I know that you guys are effectively Ramelia aligned, and so that fixes a ton of crap for us, right off the bat. And then the other thing, I mean, you guys might be willing to push boundaries more, right? Might be willing to do things with the tools that we have that, oh, like you shouldn't do that. Oh, that's dangerous, or oh, whatever. Like the fuck, Malia don't care. Malia's in charge. We can just do anything now. So that's actually probably one of the main reasons is alignment. And then the other one is that we are interested in the tech itself. And I mean, like, who else is doing it? You guys were, as far as I know, the first, at the very least, to be doing quantum compute in the way that you're doing it, as far as I understand it, right? Which is through no, okay, correct me if I'm wrong here, because I probably am. Through you guys have developed algorithms that reduce times of compute on NVIDIA's by NVIDIA GPUs by what is it, like 35x?
Well, I mean, like, so a good metric is like you can guarantee that you can use a third less compute. That's a pretty conservative metric, and if you highly optimize the system, it could be as much as like 1/100th of the level of complexity required to solve the same problem. Because effectively, like what quantum computers are really good at is higher order factoring, which is what a lot of the sort of matrix confusion calculation of quantum computing, or sorry, of AI and sort of those data inference problems are sort of based on. So by effectively, my whole premise sort of since day one has been even on a low qubit system, you can offload like significant aspects of the calculation because effectively, depending on how the system scales, you get a pretty big savings on anything where you're doing a probabilistic calculation. So quantum computers are really super good at looking at some order of scale probability wave collapse phenomena effectively spontaneously. So you don't need to go through like a Monte Carlo system or something like this. You don't need to, generate a bunch of, subchain calculations based on some seeded deterministic process that you try to dope into being like not truly not deterministic. You get like an actual like literal Higgs scale like spontaneous waveform collapse that you can actually use to compute like whatever sort of vectorial like spin configurational kind of field value you want. So for most people that's just going to be a float. Like it's going to be like a double, it's going to be a random like set of bits or something like that computed on a ridiculously short, scheme or something like that. From the point of view of like quantum computing or something like this, it's much more interesting to think about it in terms of like, the physical waveform probability, particle physics issue. Like, again, like I'm not really a big woo-woo guy, despite being like, pretty mystical and, people know that I have a sort of a bent towards a particularly, Hasidic kind of a point of view. But the point is, ultimately, like, the mechanism by which like these systems work is by something that we would consider mechanical in like some very like logical way. And it's not that interpretations are incorrect. Like, I myself subscribe to so-called hidden variable theory in the form of like Bohmian mechanics. That's literally what my whole sort of theoretical underpinning actually is. But at the same time, I think actually, we were talking about like, oh, this being like anti-Newtonian. No, I want to be completely honest with you that like I myself believe that you can use a form of like modified Aristotelianism that's effectively equivalent to, a Newtonian system defined by some sort of, differential geometrical conformal map that allows you to effectively obtain, general relativity, not as like and this is, by the way, like a pretty well-known theory that like you can use modified Newtonian gravity in the sense of building a dark matter model that actually conforms pretty well to expectations. And it should be no surprise because Gauss himself effectively modified, Newton's theory to create the underpinning of the sort of the divergent argument for gravity that became Einstein's argument for general relativity. So I guess what I'm trying to say is like, it's not. I think there's a kind of a misnomer in the kind of public perception of the scientific community. No doubt stoked by ego and all these other issues. But the point is, uh, in science, we're not really arguing with each other in the sense of like, this person is right and this person is wrong, or this argument is wrong and this argument is right. We're really trying to, build a sort of a heuristic model that allows us to explain a broad variety of phenomena accurately, giving us like predictive metrics. So like a lot of energy, I think, is wasted in the sense of like, is this person wrong or something like that, or what's wrong with this person's point of view or something like that. And it's no doubt, byproduct of the sort of the degeneration of the scientific conversation as it relates to sort of the public kind of modus communico or something like that. But the point is, uh, we're really trying to develop like these modal structures that fit really nicely into frameworks that can be used in a reusable fashion. So I think that's where like projects like yours have a lot of value in terms of like decentralized science, of which like, you recognize that what we're doing sort of was a pioneering movement in this field. I mean, regardless of the application of the quantum computing or anything like that. But anyway, it was really wonderful having you up on stage. I think everybody should take a look at your project, and I think we're going to continue to speak to each other in the future. And we're definitely. And by the way, in terms of what you can actually run immediately, remember that we're running basically the lowest bit per energy usage platform in the entire world in terms of like our learning system as a general learning framework. So hypothetically, you could have micro builds of things that run on even the least complex systems. By the way, this is something that we will continue to speak about in the future, but I would love to speak more about how the complexity of neural networks literally relates to, things like human brain growth and cellular growth through like our own life cycle. For example, babies to adulthood to, maturity, etc. I think there's a lot of insight in which like, AI research and neuroscientific and biological research can backfeed into each other, and it sort of promotes an overall greater understanding and richer point of view that allows us to solve a lot of really interesting and significant problems. All right, so thank you very much for coming up here. We really appreciate it.
Yeah, thanks guys. I'll hop down, but that was awesome.
Yeah, let's schedule some more time to talk again soon off space, and we can chat a little bit more in depth about some of this. I'd like to do that.
Yeah, I need Chachki to come over and run my project.
Yeah,
But
we'll see.
thanks
We'll
a lot,
see.
guys.
There's a cost associated.
By the way, I do want to give some credit here to Chuba because little do people know that this was actually a dream of his to launch a very similar project, and we are still going to do it, but it's going to be in the form of an in-house lab in the future. When we, by the way, this is where I really want to bring the Ramili Rabbi up on stage here, because there's some interesting things that have happened with regards to the economic sort of portrayal of cryptocurrency as tangible assets, as viable storages that are recognized by various world governments. And I think this is where sort of the broader conversation with regards to energy consumption, cryptographic technologies, and even potential, scientific and commercial tech growth might actually be of the utmost primacy. So, if you would, dear Rabbi, please come on stage.
I mean, I think there's an interesting sort of correlation here between like the tokenization of everything and the way that governments are sort of corralling different energy monopolies. And I think you're kind of seeing this shift here with just like the way, everyone in the Bitcoin community, sort of founded this whole crypto vision just as a extrapolation of like fundamental energy demands, right? And that's kind of what a lot of Bitcoiners understand about computing. That's like their whole angle on this thing. And for Chachki, that is a critical part of the vision, right? This whole reshifting in how we understand energy and energy usage. And currently, like there's just this scale up model of everything, and we all know that's not going to work forever. So we have to sort of shift the way that we are thinking about those energy usage. And I think for Chachki, the way that crosses over within crypto is kind of reducing that energy demand, which has always been a major concern for everything. And we could talk about this if you want, but for me, there's a larger shift, as we see today with like the crypto reserve in governments and Nayib Bukele, and even I guess you could kind of say Argentina's interest in this, whatever interest that was, right? Crypto clearly has some sort of backing from the banking cabal, and this banking cabal has existed for centuries now. It's very pertinent, I think, when you look at the nature of the energy transition in states like Texas, the way that the Bush family has been involved for, decades, in that sort of transition. It's pretty clear that computing is kind of along these same lines. So for me, I think where Chachi kind of fits into all this is really bringing a more efficient usage of that energy. And I think everybody in the investing world, whether they know it or not, what investing is really about is inefficiencies and rebalancing of those inefficiencies. And money is the thing that sort of balances that system, right? It's the weighting mechanism of everything. So, where you put your money should really be about like where you see the energy demand efficiencies changing, and evolving over the future. That's kind of, the angle that I've taken for everything, at least on this project. I don't know if Chachki wants to jump in there or anybody else, but I think most people in crypto sort of understand that there is this, I guess you could say, government interest, whether however deep you think that goes. Um, there is going to be a point where the energy, I guess, monopoly that the U.S. has on things is going to come to bear, and I don't think most people in the world sort of understand what that means, even for things like robotics. If you're talking about you're really funding thousands of like super soldiers, right? I mean, to really do that, you need the minerals and resources, and China understands that. But America also seems to understand this game, and there's only so many countries that can play at this. But the way to transition into that is quantum. You're not going to reduce these systems down to be able to use energy efficiently in those small packages, right? And look at what Anduril's doing. Look at the way drones are shifting warfare in the Ukraine, right? All these factors kind of align for me, and this is why I'm a big Palantir guy, right? So, I don't know if anybody else would like to jump in there, but that's really where I've seen things since day one.
Yeah, I really love that. We can't go too deep into the sort of social metaphor without going into sort of the almost archetypical like frameworks that our society itself seems to be founded in, or funded in even. It's an interesting Freudian slip there. The point is, as so deftly pointed out, Much of what we call trading is in fact based on anticipating certain divergences in expectation of consumer value placement, etc. Most of which is based on perceptions of demand that have sort of micro and sub macro and macro effects that are influenced by everything from availability of resources at any given moment to long-term future availabilities of potential mineable valuable mintable commodities or something like this, to everything from immediate power demands. Like I myself did once interview at a company that was effectively arbitrating like power usage across like a distributed framework. It was a very interesting application of effectively being able to trade futures on electricity. And as a good friend of mine, Goth, once pointed out, expect power limitation in the future as a feature, not a bug. The point is, how do you mitigate issues like this? So one potential way was trying to stimulate like social phenomena through the form of like getting people to adopt certain like behaviors, like Earth Day, let's reduce electricity or something. Now ultimately when you factor these things out, they turn out to just be basically meaningless busy work that's intended to apply to the population so that like there's some sort of like socially viable mitigatable perceptual effect of certain transformations in society based on ultimately like commodity scale, like availability and transportation issues or something like this. I think people are seeing that nowadays in the form of those airplane videos or something like this. Like I think like the way that and it's kind of funny the way that like as a society we sort of look at travel and stuff like this as being kind of the fundamental guiding um, uh, social framework that kind of defines our perception of ourselves and our environment. I mean, even the word guide implies that we're going somewhere. So I mean, again, going, walking, this kind of thing. The point being, and even point implies we're not going somewhere, right? So you can't even use language without implying that there's going to be a state that transitions to another one or something like this. So I guess what I'm trying to say is this is where where Rabbi is getting into sort of the archetypical social applicative sort of aspects of where we sort of factor in with regards to like what the ongoing conversation is. Now, the real question is the problem something people are trying to solve, or is the solution people are trying to prevent? So I guess you'll just have to stay tuned to find out whether or not that turns out to be the case. Spoiler alert, we're the good guys. So I don't know. Does Chuba maybe want to say something with regard to this?
I don't think I can top that, brother.
No, I think this is a great spot. I mean, we've been going for an hour 15. I just wanted to I guess put out like a reminder for people here, because we kind of keep every week we have a space and we have conversations that have different topics, and we kind of sometimes go off into the weeds here and there. But I think people are just maybe take a look at everything that we've talked about and start to realize that what you see on the surface is really just the surface of what it is that we're trying to accomplish here. At the base and foundational level of all that is Chachki's research, and what we deem to be kind of our quantum future. But we've talked about robotics. We're talking about on-chain integrations. We've talked about his QLLM. Different applications within that, whether that be gaming, animation stuff, and industrial stuff. We've had a lot of really interesting conversations recently with some really great companies. So we're not advertising all this stuff, and that's by design. As time goes on and we start to deliver on these things as concrete pieces, we'll start to that'll be out there. But if you're really paying attention and you're really listening to these spaces, which I know it can be hard to follow, we've left a lot of really interesting informational bits out there, I guess you can say. And you know, at the end of the day, you can realize that we're a very nimble company. You know, the core four of us here are on this space, and we're working very hard every day to build something really great. And I think you know, a lot of people in here are starting to realize that. We really, really appreciate your support. A lot of people say this is just the beginning. This is just the start. In our case, it really is. You know, we're 3 months in, and we've already accomplished some really great things, which I think, you know, this space moves a million miles an hour, and it's hard to keep up with everything. But stick with us. I think people are starting to really see the grand picture here, and I'm really excited about what we've got. I look forward to having more of these conversations, and I don't know if you guys have anything else to add. Otherwise, I think this is a great spot to wrap it up.
Well, I always seem to have something more to say. So just in case anyone was being left lingering, because the nature of this particular conversation was talking about on-chain deployables, which came to a more sort of general conversation about, uh, you know, distributed systems in the context of, you know, tokenization, for example, on the blockchain, which led to transactionalization of experience and sort of the identification that the brain itself, like a complex classical computer, has energy requirements that can be quantized. And as a direct result of that, we had a discussion about the self-organizational, you know, neuromorphic sort of learning potential present on various systems, of which, like, you know, as you know, I'm an advocate for the silicon solution, but you know, we are exploring the capabilities of, you know, effectively generating learning architecture using, you know, what you would refer to as biological systems. So, in terms of the concrete deliverables, you know, in that regard, like we talked pretty, you know, clearly about how we're going to deploy effectively dev tool level utilities on the Solana chain, and how that's going to lead to a more general sort of blockchain efficiency solution grounded in, you know, our sort of quantum principles. But just to be clear, like from a mathematical point of view, quantum computing isn't that indistinguishable from sort of a universalized algebraic sort of system. So it's again coming to terms with you know, sort of limitations in the presentation of an idea as it exists in a certain context or something like that is one of the things that we are overcoming. As many of you know, my actual background is mathematical physics. I myself, you know, I identify as a mathematician, and so sort of my point of view is a little bit less modally oriented and a little bit more sort of operationally oriented in terms of like what does this thing apply to in this context? So again, my real interest in quantum computing really came from particle physics, and that has all kinds of applications for all kinds of distributed systems, because, you know, utilizing this idea that you have, you know, the ability to sort of entangle information in classical networks, all of a sudden you can, you know, do all kinds of very interesting stuff in all kinds of distributed systems, provided that you have a sufficient framework for managing sort of the variables that ultimately allow you to prevent state collapse. So maintaining fidelity across complex networks is one of the things that I particularly specialize in. So on that, I really do appreciate that everybody came out for this one. I think we had a lot of fun. I think it was very informative, and I definitely hope that people were reading between the lines, so to speak, because as Rabbi pointed out, there are a lot of very interesting big things happening, and you might say it's a coincidence, but as all of you know, there's no such thing as coincidences. So on that note, thank you all for joining us. We appreciate so much that you came out, your attention, your time, your interest, for whatever reason, for whatever cause, whoever you are and wherever you're from. Thank you very much for coming. I have most certainly appreciated every moment I spent with you. And on that, my dear friends, God bless you all, and I'll see you again real soon.